I want to show you a trick. This is a bubblegum wrapper in my hand. You can see that I have cut it in a particular shape, thinner at the center. Why? I'll tell you that later. I can burn this piece of wrapper by using just this cell. Don't believe me? Watch this. I'm going to connect the two ends of the wrapper with my two terminals of the cell. Wow! Can you see the smoke coming out of the wrapper? Did you also notice that the smoke started coming out from the center where the wrapper was thinner? But why? That's exactly what we are going to discover in this session and also learn about the heating effect of electric current. You must have experienced the heating effect of electric current many times. For example, electric bulbs becomes hot when they are switched on. Or sometimes when we charge our phones, the charger and the phone feels warm, right? These examples tell us that when current flows, heat is produced. But why is heat produced in a conductor or device? Consider a section of wire like this. When potential difference is applied to the two ends of the wire, electrons gain kinetic energy and start moving. While moving, the electrons collide with each other. During these collisions, they lose energy and we feel this lost energy as heat. I hope you now understand that it is the collision or resistance to the electron flow that produces heat. Earlier we saw some applications where heat was produced as a side effect, such as in bulb or phone charger. But there are some useful applications of the heating effect too. Can you think of one or two such examples? Like an electric iron, where we use the heat to iron our clothes. Or an electric heater that we use to heat water or our rooms during winters. However, it's important to know how much heat is produced in every case. Otherwise, we would end up in situations like these. How we can predict how much heat is produced in any conductor. Say we have a conductor with a resistance R and there is a potential difference of V across it. The wire draws a current I. We already know that the work done to move a charge Q is given by V times Q. This work done finally converts into heat energy. So, we can also say that the heat produced is the same. That is, the heat produced in a conductor is also given by V into Q. Let's call this equation 1. Now, using Ohm's law, we can write V is equal to I into R. We also know that current is the rate of flow of charge. That is, I is equal to Q divided by time t. So, the charge can be expressed as I times t. If we substitute the values of V and Q in the first equation, we get heat produced as I square RT. So heat generated in a conductor depends on three things: square of current, resistance of the conductor, and the time for which the current flows. This relationship is called Joule's law of heating after the scientist who discovered this. Let's go back to our original problem of burning the wrapper using the cell. Hope you have understood why it started burning. The current in the wrapper produced heat and hence the smoke. But why did it start burning at the spot where the shape was narrow? Let's apply Joule's law and try to figure out why. The heat produced depends on current, resistance and time. When the wrapper is connected to the cell, the current in the wrapper is the same across all the parts of the wrapper. The time for which the current flows is also the same for the complete wrapper. But is the resistance the same throughout the wrapper? Can you see that the cross section of the wrapper is small in the center? And earlier we learned that if the area is small, the resistance increases. So the resistance is higher at the spot, which means the heat produced will also be higher. That is why the wrapper burns at this specific spot. The heat produced in the other parts was not as high enough to burn them, but the heat produced at the narrow spot was high enough to burn it. Hope you got the logic and enjoyed learning this interesting fact. Now, let's recall what we've learned. We first saw that resistance to current flow produces heat. We saw some useful applications of this. This heat produced is given by H is equal to I square RT. This relation is called Joule's law of heating. Using this Joule's law of heating, we also understood why the wrapper started burning from a specific spot in our experiment. That's all for now. Later, we will explore more about Joule's law and its application. Till then, see you soon.